Oh, very good evening, everyone. I hope I am audible. So let's wait for a minute or two so others can join. I hope my screen is visible. So, good evening, everyone, once again. In the last session, we had our project discussion and we know the importance of fast API, WebSockets. Think if it's like a building a central kitchen for a restaurant, we have the stoves, the counters, and the ability to send out dishes to all the tables instantly. It's ready to go. Seems, but a kitchen is useless without ingredients, right? Where does the data come from? For example, let me ask a question. The drawing coordinates for the diagramming tool, coordinator drawing, which we discussed, the weather data for the climate map, and the server logs for the server shepherd. Something needs to go out and collect those raw ingredients. Can anyone tell me or guess where these data come from? Just tell me for the drawing coordinates or the weather data, where does this all come from?
So APIs.
I didn't hit to database. All right. But no, it's your database, but who sends it?
So you use APIs for the to fetch the data.
You are quite close, but again, servers. Servers, all right. You're there, almost there. No, I wouldn't use this word in your last session. It starts with
Client or
A.
user?
Ah, no, client and user are some two different things. We are talking about something else. Something that needs to go out and collect those data for you. Request. It's a module what we are going to use. Again, no. Starts with A, I'm telling you. Sensors. Oh, uh, what sensors?
Fast APIs.
See, fast API is something that connects between two. See, okay. Today we are going to build simple. Today's class is going to be simple because it's going to be a foundation for that. In industry, these are often called agents. They are standalone Python scripts whose only job is to gather raw data and send it to our central kitchen or our fast API server. So we'll build two different agents today to see two very important patterns in action. All right. So let's start with our server shepherd project. The agent needs to read a log file. So how would we do that? The simplest way is to open the file and read it, right? But what if new files are added after we read it? Again, we have to run our script again and again. So that's not an agent, that's just a manual work. So agent needs to be smarter. He needs to watch the file and react when it changes. This is called event driven programming. Let me repeat, event driven programming. Instead of us checking for changes, the system tells us when an event, a file modification happens. For these, we use a brilliant library called Watchdog. Has anyone ever heard of Watchdog? Please let's install Watchdog. I have already. Can someone does it for me and give me a thumbs up when you guys are done? Have you guys installed? All right. Now let's create our agent. We are going to create a new file logtrailer.py. We are going to make it do something useful. For example, when a file is modified, it will open it and print only the very last line of it. All right, I'm going to write step-by-step codes slowly one by one. Let's work on it. Is my screen visible to everyone? All right. So we're going to import time. Guys, please do along with me because I'm using some other laptop, so I'm not sure it might work here. So I want you to tell me the output if it doesn't work. So let me just import. So essentially import what we are going to do here. Right. Now we create a handler class. This is where we define what to do when an event occurs. It's like telling a security guard when you when you see something, do this specific action. So I'm going to create a handler class as log file. Let me be more specific. All right. Okay, let me tell you this part. So the on-modified method is a special name that Watchdog only understands. That's why we are using as a default function, which only Watchdog understands. So it will be automatically called whenever a file in the directory we are watching is saved or modified. So like just say, if not, it is very pretty simple. So I don't have any explanation needed. Again, let me tell you what this is like. And now this line, the event object tells us what happened. We check if the file was the event was a file and not a directory. In the path, the start that has some log has a text file, just say agent.log. It's checking for this. Print. Okay. Like I said, I'll use try and exception always. Now we open the file that was just modified. Hit open. Now we read all the lines into the files. This is very basic stuff. See, I'm using lines, not line. Can anyone tell me the difference between read line and read lines? Anyone? What is the difference between read lines and read line? Come on, guys, be interactive, right?
So read line reads only a single line.
Perfect.
Read
See, it
lines,
is
it
there in the
read
notes.
all the lines.
Exactly. Guys, come on, basic thing, at least you can just tell it, right? Why hesitate? Thank you, Kanika. And then if lines, we get the very last line from the list. So we have to strip it for the very last line. Lines. How to strip in the sense we have to use dot strip. Uh, can anyone tell me why I have used -1? Because if you know how a list works, it starts with 0, 1, 2, 3. When in reverse, it starts with -1. So that's why I have used last line. I have stripped off any spacing, anything like that. Now this is where we would send the last line to our fast API server, this part. So we are not going to use that one now. So we're just going to build very simple agent. All right. Now comes the main part. The main part of our script that sets up each and everything. How do you going to do is We're going to call the function. Right. First, we have to set the path. The easiest way is to just add a dot. We'll watch the current directory for changes. And the event handler is equal to nothing but log file handler. We create an instance for our custom handler. An observer is nothing but observer, which we imported. So this is the actual watcher object from the watching dog library directly. Now we tell the observer what to do and where to look. Observer dot make sure of the spacing, please. So observer dot schedule. We are scheduling our event handler to watch the path. Scheduling event handler to do what? Watch the path. And we have something called recursive false. Can anyone tell me what is recursive? The meaning of recursive?
The function that calls itself.
Exactly. No. See, recursive is nothing but if we are in the file, we are in the path which has multiple folders. It won't go and check each and every folder for that log file, but only the folder, not the subfolders. That's why we have put recursive as false. If recursive is true, it will go and search very deep dive. Now we have to start the observer. So start the observer. It runs in the background on a separate thread, so it doesn't block our main script. Print of trailer. Now we have to use this loop. Just keeps our main script running. If we didn't have this, the script would start observer and immediately exit. So we have to keep it running. If true, just time to sleep for 1 second. And except because control is something which stops keyboard interrupt. Like if you press Control C, we gracefully have to stop the observer. So if keyboard this one happens, observer stop. Simple. Nothing complicated, nothing no. And now we have to join everything. Server dot join. So this waits for the observer to thread to fully shut down before the script ends. That's why we have added observer dot join. So this is our simple script. Does anyone have any doubt? So let's assume in a folder, create a new text document stating as activity.log. Okay. And I have opened that one as here. See, log trailer started waiting for any changes. Now it's watching in a separate terminal in the same folder. And now I have something called agent.log in the same file. It has exists. So if I open that, let me just type it here so that you can see there. I'm adding echo dot. It's a demo data, nothing. I'm just typing each and everything here. Give me a second. Nope, I'm not able to wait. Guys, just anyone able to run in the code? That's all I want to do is go to the file location where the file exists. Let's just say I have a folder test logtrailer.py. Just create any like just say activity.log or something like that. Create a file, log file, and just type anything. So let me just type because mine is not working because I'm using a laptop which is very old. I just say hey. Just type something there in the pad and check if it's working. Let me stop it. Run it once again. No, it's not working for me. Nope. All right, no issues. Guys, does anyone did in the PC like does it work there? Because it worked before my I'm using some laptop, so it's not working. Does anyone can confirm that? Anyone? All right, let me explain the code. No issues if you don't respond here. So what happened here is the log file we have to create checks whether the log file is nothing but a file, is not a folder. And then we read every line and we go to the last line to check whether anything has been updated. Then the main part comes here. We get the current path. Maybe the issue is the path here, I guess. Is the path. See, detected get change here. So if I make one more change, right. So what happens here, see it? Our agent instantly detected the change and print a new line. So it picks up immediately. So this is a robust, efficient agent. It's not wasting any energy checking the file consist like again and again. It just waits to be noticed. Or this is the agent what we're gonna use for server shepherd. Or this is the core of the collector for our server shepherd project. Does anyone have any doubt in this? Because I'm out of station, so I don't have my personal laptop. This is something old laptop. Does anyone have any doubt? Actually, give me a note, then I'll be fine. All right, thank you. Okay, now to our second agent. For the microclimate map, we need to fetch images from many webcams. So let's start with a simple synchronous approach. A synchronous means one at a time. We'll use the most popular library for this, request library. Let me share. If you guys don't have, please do it. So can you tell me what is request library? At least a short brief on that. What it do? Why are we using it? Anyone? Yes, it's a building. All right. The first thing what we're going to do is we are going to make request on server. Yes, Abdullah Tariq. Thank you. So let me just type it out first. So I'm going to create a main function. I'm going to add a URL here. So I have a URL. Get that. Can you explain me this part? It's very easy. I don't have to explain that one. So I'm showing you the alternative way. It's like a slow fetching way. Guys, it will be great if someone explain me what I'm doing it, so we might save some time, and also I can get to know you're like you have a very well knowledge in understanding all these kind of things. It's very easy. Like I'm just showing you a demo how we can going to fetch the data from the random website. So just in place of the URL, we're getting webcams URL where we have data. This I said in the demo class, we don't have to rely on that one. We just get some random data. I'm going to show you the efficiency also, the difference between async with and synchronized version and the unsynchronized version of request library. So this is a slow version, which is a synchronized version. I'm going to show you the time difference. Since I need in seconds. All right. Now here comes the explanation. So what's the output? It fetches one, waits, finishes, and then start the next. Waits, finishes. So total time will be the sum of all the individual download time. For 5 images, it might take 3 seconds to 4 seconds between. So for 500 webcams, how long it will take? It would take hours or minutes. So our program is spending most of its time just waiting for the network. It's like a chef who puts a pot of water on stove and just stands there staring at it until it's boiled before doing anything else. So it's inefficient, right? So we can do better. We can use asynchronous programming. This is like a smart chef. They put the water on the boil, and while it's heating up, they start chopping something else. And when the chopping is done, they just mix with the like and make sauce. So they work on the other tasks while waiting for slow ones to complete. This is what asyncio let us do in Python. So for that, we need a asynchronous HTTP library, AIO. I'm going to paste that in the command. Abdullah, can you turn your mic on, please, so I can't open chat and read your calling place, so right? But you get some yes, sir. It says yes, exactly. So please install that one. And now, if it does, we don't need this one, so I'll just read this off. Please install that one. We're going to do a better version of it. Import Essentio, which we did that. Import. Okay, so I don't have this laptop. Let me install that one for me myself. Done. So async default. It tells Python this is a core routing, a function that can be passed. So this is for our chopping vegetable task. I'm going to use default function. The function name is fetch image. We're going to get sessions here for multiple things so that multiple things happens multiple times. That's called sessions. For most efficient way, we use that one. All right. So async with is a asynchronous version of with. like with open with something, but the asynchronous version, multiple things happen at the same time. URL. As if I'm making some mistakes or somewhere, point it out for me. As I'm doing it fast. All right. So session.get starts the network request. The await keyboard is what actually passes the function. It says, I'm about to wait for the network. If there are any other tasks to run, run them now. For example, if one image is downloading and the network is trying to load, it will stop there. But same time, the other image will start to load so that it doesn't wait for anything. Just like using multiple Chrome browser for multi-tab support so that you can do multiple things at the same time. Oh, these are some extra things I'm adding for you to know how many bytes the difference and the weight happens. All right. Now comes the main function. So these are asynchronous part. This part has nothing to do. This is the main part, main function, main brain of it. So URLs. So the same thing I'll get from the last time. Now we create a client session to sync with using AIO HTTP. All right. And we create a list of all the tasks we want to run. We're not starting them yet. We're just giving our like chef the list of recipes. So we're going to add task and we are going to say fetch what image from here. And the same thing as a session URL, all we are going to write. And now part comes here. As you can see, we have URL and URL. Yes, so I'll show you the difference because we can't keep the both seeing the same name. So for URL in URLs, now it will get linked. So this step is like a magic. Asyncio dot gather task. So this is the chef saying start all the recipes all at once right now. Don't wait for anything. Do not wait for anything. Starts everything all at once. So it runs all the tasks concurrently. It will be done only when the last task is complete. It won't stop until then. So I'm adding print message to check when it's going to get complete. And now for I results, now I need all the data, right? So I'm going to use enumerate results. And if results print, Now we have done the main part. And now this is how we kick off our entire function by start time is equal to time.time, calling the async show function dot run what main. Oh, this is where everything going to run. This starts the async event loop and runs all the main functions until the main function gets exhausted. That is no task is there to execute. Let me. Why it's not working? Maybe I just did stall. Give me a second. Let me reopen once again. See, so all the tasks, all the starting fetch message appears all at once. Look at the bytes of the data. Look, starting. Everything appeared all at once. The program fires of all the requests without waiting for anyone. Then the finished message trickled, and each download is completed. Finish. And look at the time, 0.7 seconds. It roughly the time took for the single slowest download to finish, not the sum of all them. This is the power of async that is an asynchronized version. Does anyone have any doubt? Come on, guys. Any clarification? Kanika, Tarek. The reason why I told this one, because you guys must be thinking, how can we get the data for these two projects? Like if we have been wondering, how can we get a demo data for webcams? This is one of the ways. How to agents checks the data. So this is how we can check the data. It's very simple until you know the meaning of it. So today we build two agents. One is event driven, software for reacting to things happening on the local machine. The other is asynchronous, perfect for handling many slow network operations at once. The final step, which we won't code today, but it's crucial to understand. The log trailer won't not print the new line. Instead, it would use a WebSocket client library to connect to our fast API server and send the log file. And the fast fetcher would not just print the images were downloaded. It would take the image content, maybe run it through the AI module, and then send the result, example, whether it's a sunny or a shady, to our fast API server. So these are agents or handies, like these are the hands and the eyes for our fast API server is a brain that receives all the information and tells the front end what to display. Well, let me say a key concept. An agent is nothing but a specialized program whose purpose is to gather data from a source like a file or a sensor or a web API. You can use anything, Abdullah. So they are like a data producers agent. Now the difference between synchronous and asynchronous is synchronous nothing but the tasks are performed one at a time, and in a sequence, the program starts the task and waits for it to finish completely before starting the next one. Example, a person making a single phone call waiting for it to end before they can dial the next number. Whereas asynchronous nothing but task can be started and the program can move on to another work while waiting for the initial task to complete. This allows for handling many operations concurrently. Example, a receptionist at a business office who can answer one call, put them on hold, and answer a second call, and switch between them as needed, whenever sitting idle. What is event driven? I've used the word many times here. A programming style where the program's flow is determined by event. Let's say a mouse click, a key press, or a file being modified. The program listens for the events and reacts when they occur. So we have covered a lot today. So moving from simple synchronous code to powerful event driven and asynchronous patterns, these are fundamental skills for building any application that needs to gather data efficiently. Does anyone have any question? Anyone? You can respond it by turning on the mic. It would be great, guys, because I don't like to have one-way communication. Anyone would like to convey something? So this is a starting function which we did. So from next sessions, we are going to deal with directly with React. We are going to build front end, back end, full applications. Async. See, asynchronous version is something which is a new, and not all programming language can handle that one. Because as far as I know, not all programming languages are capable have capability to run in on loop and do stuffs all together all at once. All right, guys, if you guys don't have any clarification, then we can wind up. Thank you guys for joining and have the rest of the night great. Looking forward to seeing next sessions.